Good evening, everyone. Welcome to Neet Chemistry live classes in English. My name is Appal Naidu. I pursued my MS in Organic Chemistry from Andhra University. I have 4 years of teaching experience in Neet and IIT I am I am happy to announce that from today onwards, I am going to take live classes in this YouTube channel. Today is late to take the live classes, but tomorrow onwards, I will take the live classes sharp 8 p.m. Okay, na? 8 p.m. I am requesting everyone to attend and join the live classes. And the next point, in the previous live video, we discussed about the introduction of haloalkanes and haloarenes. In this video, we are going to discuss about this is the part 2 of haloalkanes and haloarenes. In the previous live classes, we discussed about introduction of haloalkanes and haloarenes. In this video, we are going to discuss about the classification of haloalkanes and haloarenes. Okay, why I'm started from organic chemistry? Why? Because most of the students feels that organic chemistry is difficult. That's why I take I take explanation from organic chemistry first. Okay, na? And most of the questions we observed that NEET 2023 or previous year question papers we observed that mostly 19 questions are from the organic chemistry, that is +1 and +2. This is also one of the reason why I start explanation from organic chemistry. Okay, these are the 2 points why I am explaining organic chemistry. Okay, now let us try to understand. Now let us jump into the today topic, that is classification of classification of haloalkanes and haloarenes. So I am requesting everyone to must follow my channel. Please follow my channel. I'll help you to throughout the year up to May 2024. And please do subscribe for more videos and updates. And please like the video if and only if like you like the video. Okay, and please do subscribe for if you feel that this YouTube channel is helpful to you. Okay, na? Now let us jump into the today's topic, that is classification of haloalkanes and haloarenes. The haloalkanes and haloarenes may be classified as follows. The first one is, what was the first one? The first one is the first one 6.1.1 on the basis of number of halogens attached. That means for a given carbon, how many halogens are attached. Here we observe that here only one halogen is attached in this carbon to this carbon. So its name is monohaloalkane. And we here observe that for two carbons, two halogens are attached. That's why we call dihaloalkanes. Here we observe that three carbons, three halogens are attached. So we call the trihaloalkanes. In this way, that means how basis on the number of halogens attached to a carbon atom, we categorize as a monohaloalkane and dihaloalkane, and the third one is a trihaloalkane. If four carbons are present and four halogens are attached, what's the name of this compound? Its name is tetrahaloalkane. Its name is tetrahaloalkane. It's a name. Okay, if five carbons and five halogens attached, what is the name of this compound? Pentahaloalkanes. Pentahaloalkanes. That means here we observe that how many halogens are attached? Four halogens. Here, five halogens. That's why pentahalo, halo. That means pentahalo halogens. Okay, pentahaloalkanes. Okay. Now let us try to understand here benzene group is benzene. Here one halogen is attached to this benzene group. Here we also observe that monohaloarenes. If two halogens are attached, it is called dihaloarenes. If three halogens are attached, it is called the trihaloarene. In this way, the classification on the basis of number of halogens attached is completed. Here we observe that this is an we call as an aliphatic. Why? Because straight chain. these compounds are called the aromatic. Why? Because benzene ring is present in to this benzene ring, one halogen is attached. So this is called the monohaloarene. Okay. What do you mean by herene and what do you mean by haloalkanes are explained clearly in halo introduction of haloalkanes and haloarenes. If anyone missed the video, please go to the playlist of Neet chemistry live classes in English and haloalkanes and haloarenes lesson and watch the part 1. And if two halogens are attached to this benzene ring, so it is called dihaloarene. If three halogens are attached, this is called the trihaloarenes. Okay, now let us see the further classification. That means monohalo compounds may further be classified according to the hybridization of the carbon atom to which the halogen is bonded as discussed below. Here, this two lines stated that this how many halogens are attached further may classified as how what is the hybridization of this carbon. That means here halogen is attached to this carbon. What is the hybridization of this carbon depends upon this. These will be further classified. Okay. Now let us discuss the next point, that is 6.1.2, that is compounds containing sp3 hybridized carbon bond halogen. That means here the halogen attached carbon undergoes sp3 hybridization. That means that's that means here the carbon surrounded bonds are single bonds. Okay, this type of attachment undergoes the carbon sp3 hybridization. Here we observe that the halogen attached carbon having the hybridization sp3. Now let us try to understand the this paragraph, and this total paragraph will explain by taking of these examples. Okay. Now let us try to understand first one, that is alkyl halides, haloalkanes. Okay, both are same. What do you mean by alkyl halides and the haloalkanes are explained in introduction of haloalkanes and haloarenes. If anyone missed that video, please go to the playlist of haloalkanes and haloarenes. Was the part 1. In alkyl halides, the halogen atom is bonded to an alkane group. Okay, they form homologous series represented by that. This is the general formula. Here we have to remember this general formula. That means Cn H2n plus 1 halogen. Here we observe that, for example, 2n plus 1 halogen. Here X means halogens. Try to understand what do you mean by halogens. Halogens are fluorine, chlorine, bromine, iodines are called halogens. For example, if you take n equal to 1, it will become C1 H2 into 1 plus 1 into halogen. It will give rise to C1 2 plus 2 into 1 2 plus 1 3. So H3X, that gives rise to CH3 halogen. It is called the methyl. It is called the methyl halide. This is called the methyl halide. So the general formula of haloalkanes and haloarenes is CnH2n plus CnH2n plus 1 into X. Okay, na? Here X means halogens. Here we try to understand what do you meant by halogen series. The halogen series, which means the difference between two compounds. For example, here CH3X. Next compound is CH3 CH2X. Here we observe that the difference of CH2 group. Okay, the difference of CH2 group is called the series, the two compounds which are homologous series. When we observe two compounds, the difference is bond CH2 group. That group is called the homologous series. And next point, they are further classified as primary, secondary, and tertiary according to the nature of carbon to which halogen is attached. Okay, depends upon the how halogen is attached to carbon. They will classified as a primary, secondary, and tertiary. This concept will explain by below example. Okay. No problem. If halogen is attached to primary carbon atom, alkyl halide, the alkyl halide is called primary alkyl halide. If halogen is attached to secondary and tertiary carbon atom, so it is called the secondary alkyl halide and tertiary alkyl halide. Now let us try to understand what do you mean by primary alkyl halide, secondary alkyl halide, tertiary alkyl halides. Here we have to keep this concept throughout in organic chemistry. Why? Because this concept is very important with respect to exam point of view. Here in this place X means we've discussed it previously. X which is means halogens. The X may be fluorine, X may be chlorine, and X may be chlorine, and X may be bromine, and X may be iodine. And in this place, OH group is also okay. For up to this, here we have to understand that here this halogen is attached to this carbon, which is having two hydrogens. Okay, we have to remember this halogen attached carbon having the two hydrogens. So this carbon is a primary alkyl halide. You have to keep in mind that when halogen attached carbon having two hydrogens, that carbon is called the primary alkyl halide. And the next second one, if halogen attached carbon, okay, if halogen attached carbon having the only one hydrogen, so it is a secondary, so it is a secondary alkyl halide. And next third one here, halogen attached carbon, there is no presence of hydrogens. That means absence of hydrogen. So this carbon is categorized as a tertiary alkyl halide. In this way, you have to remember what do you mean by primary alkyl halide, secondary alkyl halide, and tertiary alkyl halide. What is the trick that here we have to see this halogen attached carbon having the how many number of hydrogens. Here we observe that this halogen attached having the carbon having two hydrogens. Here one hydrogen, two hydrogen means primary and one hydrogen means secondary, and no hydrogen. There is no presence of hydrogen means that is a tertiary alkyl halide is present. I hope this concept, this classification is clear to you. Now let us try to understand the second one, that is allylic. These two are important with respect to exam point of view. I hope most of the students see the 2023 question paper. We have a question on allylic. We have a question on this topic, that is allylic, benzylic, and the last one is vinylic. These three functional groups are very important with respect to we have to identify what does mean by allylic, what does mean by benzylic, and what does mean by vinylic. In 2023 question paper, we have a question on this topic. So these topics are very important with respect to exam point of view. Okay, now let us try to understand what does mean by allylic halogens. Okay, these are the compounds in which the halogen atom is attached to an sp3 hybridized carbon atom, which is adjacent to the carbon-carbon double bond to an allylic carbon. Here, the only hint is given that the halogen attached carbon, okay, this carbon undergo sp3 hybridization, but remaining these two carbons. When double bond is involved, this carbon hybridization is sp2, and this carbon hybridization is also sp2. So we conclude that CH2 double bond CH bond CH2 bond halogen. This means this halogen attached carbon having the sp3 hybridized, and this carbon is sp2, and this carbon is sp2. In this way, you will identify the allylic compound, allylic carbon in a given functional group. Okay, na? And next one. Okay. Next here we observe CH bond CH2 bond halogen. So this carbon hybridization is sp3, and adjacent carbons hybridization have sp2 and sp2. In this way, you will identify that here allylic functional group is allylic halides are present. Okay. I hope how to identify an allylic halide is clear to you. Clearly, the halogen attached carbon is sp3 hybridized, the adjacent two carbons are sp2 and sp2. In this way, you will identify the allylic carbon. Now let us try to understand the benzylic carbon. Here, the benzylic, these are the compounds in which the halogen atom is attached to an sp3, hybridized carbon atom to an aromatic ring. Here we observe that this is all about the aromatic ring, but the halogen attached carbon hybridization here is sp3. Okay, this type of compounds are called benzylic halides. Okay, here in place of 2 H2, here methyl groups or alkyl groups are substituted. So this is called the, here we observe what is the this group is primary, secondary and tertiary. How will you classify this? Here the halogen attached carbon. Here we observe that there is no of that means absence of hydrogen. That's why this carbon hybrid, this carbon is tertiary halide. This carbon is tertiary halide. For example, in case of instead of replacement of two hydrogens, only one hydrogen replaced, remaining will be same time. So this halogen attached carbon undergoing a hybrid that is a secondary halide. This way, this is the primary halide in primary benzylic halides. This is secondary benzylic halide. This is a tertiary benzylic halide. You have to classify them. Okay, I hope allylic benzylic halides are clear to you. Now let us try to understand the last one, that is the compounds which containing the sp2 hybridization. Now let us try to understand what you meant by sp2 hybridization. That means here the carbon if a double bond between carbon and halogen attachment is present. So this halogen attached carbon undergo sp2 hybridization. This format is called the compounds containing sp2 c bond halogen bond. That means the halogen attached hybridization of this carbon is sp2. In previous allylic and benzylic carbons which are undergo sp3 hybridization. That is the difference. Okay, in sp2 carbon bond halogen type we have two types, that is vinylic halides and aryl halides. Now let us try to understand what does mean by vinylic halides. In vinylic halides we observe that these are the compounds in which the halogen atom is attached to sp2 hybridized carbon atom of the carbon-carbon double bond. Okay. Now let us try to understand comparison between the allylic and vinylic. These two are very important with respect to exam point of view. That's why I am explaining comparison with the allylic. Okay. Here this one is vinylic and the next one is allylic. Here H2C double bond CH bond halogen and allylic, which means CH3 bond, sorry, CH2 double bond CH2 halogen. Here we have to point out the what is the difference between them. Here we observe this halogen attached carbon undergo the hybridization sp2. Okay, this halogen attached carbon undergoes the hybridization sp3. This is the major difference between the vinylic and allylic halides. Here in allylic halides, the halogen attached carbon having the hybridization sp3, but in vinylic, the halogen attached carbon undergo the hybridization of sp2. This is the major difference between the vinylic and allylic. Okay, and now let us try to understand the hybridization remaining here sp2 and sp2, and remaining are sp2 and sp2. For example, in a given compound, you have to identify that whether the vinylic and allylic halides are present. So a simple trick is that for example, if the given compound is allylic, the hybridization is the first halogen attached hybridization is sp3 and remaining two carbons are sp2 and sp2. But if this compound is vinylic, the halogen attached carbon is sp2 and adjacent carbon will also undergo the sp2. There is no sp3 in vinylic halides. In this way, you have to identify the given compound as vinylic or allylic. I hope the comparison between the vinylic and allylic compounds are clear to you. Now let us try to understand the aryl halides. The aryl halides, which means the halogen atom which is directly attached to aromatic. That means here carbon hybridization is sp2. Why? Because the carbon which involves in double bond, that's why its hybridization is sp2. Here is the two examples of aryl halides. These are the compounds in which a halogen atom is directly bonded to sp2 hybridized carbon atom of an aromatic ring. Here, this halogen is directly attached to benzene. That means here this carbon hybridization is sp2. This is called the aryl halides. This is all about the classification of what does mean classification. That means the first one is classification of halogen atoms. That means number of halogens are attached, and the halogen is attached to sp3 and sp3 hybridization. That means here allylic and benzylic halides are discussed, and the halogen is attached to carbon which undergoes sp2 hybridization. In this, vinylic halides and aryl halides are discussed. I hope comparison between vinylic and allylic compounds are clear to you. Why? Because these are very important with respect to exam point of view. You may check 2023 paper. Now you are able to answer that question. If any person, those students who are not able before, now once see the previous year 2023 question and answer the concept which is present on vinylic and allylic. I hope this concept is clear to you. If anyone does not watch the part 1, please go to the playlist and watch the part 1 also. And this is the part 2 of haloalkanes and haloarenes. From tomorrow onwards, I am taking live on 8 p.m. Please fix the alarm 8 p.m. every day 8 p.m. From today onwards, we are going to take classes up to May 2024. Okay. Please fix your alarm at 8 p.m. and please follow our channel and please do subscribe for more videos and updates. And if this video is useful to you, if and only if this video is useful to you, please like the channel and please like the video and please do subscribe for more videos and updates. I hope